Hi. So welcome to lesson number 5, module 4 of the Big Data and Hadoop developer course. In this particular lesson, we'll be having a demo on the MapReduce job operation. Now, before we jump right into the demo session, let's have a quick recap of the previous lesson. So in the previous lesson, we have learned the concept of mapper and reducer in depth. So in this particular lesson, we'll be explaining the MapReduce job operation by picking up a practical code and an example. Now, we will use the same example that we have used in the previous lesson, which is the word count program. Now, the objective of this particular program is to count the occurrence of each word. Now, the different steps that are involved in this particular program is we have to define the mapper, reducer, and driver class first, then load our input data into HDFS, then we'll execute the actual program which is running the jar file, and last but not least we'll check the output and verify whether it is working fine. So here, as you can see, I have created a text file which contains our sample data. So it is the same data that I have used, the name of some people like Jack, Bill, Joe. So create this file and give it a name such as input file 1 and save it on your local file system for reference. Now, here is a sample MapReduce program executing the map method. Here the arrow number 1 shows the map method. The map method reads the input data line by line and it is represented by the value parameter in the map method. So the input to the map method is a key value pair in fact. And here the key 0 and the value is Jack, Bill, Joe. So what we have to understand here is the key here is 0 because the framework already could have calculated the key value pair, and the value will be the first line which is Jack, Bill, Joe. Now we have to convert the textual value into a string type. Now the string variable line will store the Jack, Bill, Joe value. So we are declaring a new variable called line of string data type, and this is going to store the value Jack, Bill, Joe. So you can see the command or the code snippet for the same in arrow number 2. Now, once we are done that, will create the object of string tokenizer class to handle our string value, which is shown by arrow number 3. Now, the reference variable tokenizer hold the address of all the values here. Now we also have a while statement that takes the parameter tokenizer dot has more tokens. Now this method returns boolean values whether yes or no, right? Now if there are more tokens, what happens is that it will return true and the control will be gone inside the while loop. If there are no more tokens, then the execution will stop. Now what will happen inside the while loop is that the first statement of the loop is value.set tokenizer.next token. This will set the tokens on the value variable. And here the token Jack is assigned to the variable value. And finally, we'll write our intermediate output using the context.write method on the local file system. Then at last, we'll have the output like Jack, 1, Bill, 1, Joe, 1. Now this is the reducer class and we'll call it as reduce, and this is shown by the arrow number 1 declaration of the reducer class. Now this extends the standard reducer class. Now if you look at arrow number 2, you can see the reducer logic. Now what the reducer method does is that it takes input as a key value pair, because the shuffle and sort phase will give it as a key value pair. The key is of text type and the value is int writable. Now here the key will be Bill and the values will be 1111 if you take the first key as an example. Now the reduce method will be called for each key. If we are having, let's say, 5 keys, the reducer method will be called 5 times. After that, we'll declare a variable, and here we are calling the variable as sum. The variable has been initialized to a value of 0. all the values of a key will be added and they will be stored in the variable sum. And here you can see that the key is Bill, and 4 ones, which implies 4 values of Bill, will be added and incremented and stored in the variable sum. Now finally, we'll use the context.write method to write the output. The first argument of context.write is a key, and as you can see, the key here is Bill. And the second argument is sum, whose value for Bill will be the digit 4. Now this is our first tokenizer mapper.java file. If you can look at the first line of code represented by arrow number 1, this is the package name or the package statement. Now here the name is com.skillspeed.maven.wordcount. In the next arrow, arrow number 2, you can see that we are importing 5 predefined classes. Now the classes are, one is IO exception, which handles input and output exceptions. Second class is string tokenizer, which basically breaks the input file into words. The third one is int writable, which is used for integer. The fourth one is text, which is a wrapper for our string data type, standard string data type. And the fifth one is the mapper class. Now next we'll have a look at the mapper class. This is shown by arrow number 3. Now the tokenizer mapper class extends the mapper class. Now we'll declare 2 variables as you can see from arrow number 4. The first one is called 1, which is of int writable. The second one is called word, which is of text type. Now if you look at the arrow number 5, that actually explains the map method implementation. Now the map method reads the input data line by line and is represented by the value parameter in map method. Now at this stage, the data is broken into tokens using our string tokenizer class. Now the reference variable itr show the address of each token. The while statement takes and it passes it to itr.has more tokens. This returns a boolean value, and if there are any more tokens, then it will be gone inside the while loop. Now as you can see, the while loop has the first statement word.set itr.next token. This will set the tokens on the word variable. So for example, if we have our input file containing John, then John will be set on the word variable. Now in the same package, we'll create the reducer class. So the arrow number 1 is the package statement. You can see the arrow has 4 predefined imports such as IO exception, int writable, and text and reduce class. Now let's have a look at the reducer class declaration. Now if you look at the arrow number 3, you can see that we are declaring the reducer class. It's called as int sum reducer, and it is extending the reduce class. Now if you look at the arrow number 4, you can see that we are declaring a variable. It's called result, and it is of type int writable. Now this is used to show the final result. Now the arrow number 5 summarizes the logic that we are going to use. Now the reduce method takes input as a key value pair. The key is of text type and value is of int writable type. Now it will be called for each key. For example, if we have 5 keys, the reduce method will be called for 5 different times. Now after that, what happens, we are declaring a variable called sum here and initializing that to 0. Now all the values of a key will be added and they'll be stored in this particular variable called sum. Now set the sum to the variable result, and finally use the context.write to write the output. Now at last, once this is running, we will have values like Bill 4, Don 4, Jack 6, and Joe 4. Now this is the driver class, and as you can see, arrow number 1 is the package and arrow number 2 are standard imports. Now in arrow number 3, we are defining the class, public class word count. And if you look at arrow number 4, we have our public static main method. Now, if you look at arrow number 5, then that is where the actual declarations happen. So if you look at arrow number 5, what you can see here is We are creating an object of configuration class to define the Hadoop development environment. Now then we will create an object of MapReduce job and we'll define the state of the job object by configuration object and job name. Now here you can see that the job name is word count. Now we'll run this job on cluster and we'll pick up the job into a jar file. Hadoop will use the setJar by class method to locate the relevant jar file by looking for jar file containing the classes. Then we'll declare the driver class, mapper and reducer class. And as you can see, next we'll define the output key and value. Now as you can see here, the output key is of text type and value is of int writable type. We're also specifying the input path by calling the add input path method on file input format, and our path is specified by calling the static set output path method on file output format. And the last line of the job code is job.wait for completion method. Now this method is submit the job and wait for it to finish. The return value is boolean, it indicating a success for 0 or a failure for 1. So this is also shown in our code example. Now as you can see here, we are uploading the particular file to HDFS. The command is hdfs-put and the file that we have created, and root, which is the location. Now this is the command to run the jar file. Now the command is hadoop jar word count.jar, which is located on desktop, input file, which is our input, and the output is /wc output. Now what we need to understand here is that the output directory should not exist on the Hadoop distributed file system. Now once the program successfully finishes, we can check the output by typing hdfs dfs-cat / the output directory, which is wc output /part -r-00000. As you can see, the word count program successfully ran, giving us the output of each word in the input file. So to wrap up, in this particular lesson, we have demonstrated the code snippet and ran a word count example successfully. That's all for this lesson. If you have any questions, please do not hesitate to raise a support ticket. Thank you.